there, I'm Zeke, KJ7NLL, and today I'm going to tell you all about these flex boards for my desktop satellite tracker. But first I'd like to give a special thanks to PCBWay for providing me with these awesome flex boards. So here we have a flex board and a circle board, and it's going to go into my desktop satellite tracker, and you'll notice there's all these cutouts in it. Those are bend points for it to bend at, and so this motor will just pop in there like that, and then this flex board will control it all with our code. So let's do that. So now I'm pasting up the flex board, and now it's going to heat up as I place the components. And so there's quite a few components to place. And then I'm going to place the compass chip, which is a tiny wafer chip, and the accelerometer chip, and then it's going to heat up. So a few of the problems we had with our flex board is, number one, we have this motor, and so the motor pads where it attaches kept breaking off, and the reason they were breaking off is because when I was trying to put it into my desktop satellite tracker right here and put it into this tube, it would break off the connections because this is being pulled on so hard trying to get the C assembly on and off, which just slips up and down. So when the motor pads broke off, not only did they break off, but also the traces attaching to those pads, meaning that we had to run little tiny wires to get to those places. So now I'm going to take apart my desktop satellite tracker and replace the old rigid boards with flex boards. But as we know, this doesn't really work, and the pads on the motors came off when I tried to put Phi on. So I take it apart, and I will solder it and put it back together again. And then now here are some fixes for these problems. You can make the pads where the motors connect bigger, and so that will decrease the chances of the entire pad coming off. You can make the solder mask smaller so that it encases the copper more, and you can add teardrops on the traces to prevent cracking. And for this, and the tightness of not being able to get the Phi arm onto it, we can add little connectors here so that the motor and the flex board can just slip right into a connector on this circle board. So now I'm in KiCad, and I just wanted to show you what teardrops look like. So this is a board without teardrops. Notice how it's just straight in, and there's nothing really to make it a nice angle towards the pad. But we want an angle, so I'm going to go to Tools and add teardrops, and then just hit OK. And it's going to add a bunch of teardrops everywhere so that it connects more of the pad, and that will make it, if I refill this, that will make it less likely to break off the trace. And in 3D, this is what it looks like. We have, oh yeah, and I forgot to mention bigger motor holes because the motor holes were too small and it was bending, so that could cause problems. But notice how the angles teardrop into the pads, and that makes it so that it's less likely to crack right there. Now we'll have pictures of the solid boards, which replaced the flex boards when they didn't work, and they are inside here, replacing the magnetometer and the accelerometer. So the way that I got these fixes for the flex board is I reached out to PCBWay and got in touch with one of their engineers, and they suggested adding teardrops and making the solder mask smaller than the copper and making the pad size bigger. So another big thanks to PCBWay for helping us fix the flex board problems, and we will be ordering new boards with them again soon. So in this video, we talked about the differences between the flex board and the rigid board, which was a replacement for the flex board, and we also talked about teardrops and the desktop satellite tracker. And so, thanks for watching!